is there only one fried sausage?
Yeah, so that'd be a
Yeah.
trapezoid.
Okay, that makes sense, thank you.
And isosceles trapezoid is not equal.
I have 2 in everything except for quadrilateral.
No, I have the same thing as you.
Oh,
That's
yeah.
A isn't a trapezoid because trapezoids
isn't
have to have
anything,
one
right?
pair of parallel
Wait,
sides, so
where's
it has
H
to be in
I have H
quadrilateral.
in parallelogram
But it's
and
an
rhombus.
isosceles. Because
Okay.
with equal non-parallel.
Okay, that's good. That's good. Oh, you got a K and I have an H.
What?
What'd you put K as?
I got it, but then
Oh,
I
I don't
used
have
like
K.
everything.
That's probably a problem.
Gotcha. Wait,
so-
so.
Where
did you put
A?
Oh. Oh, that
she's
makes sense. Okay.
G and then.
Yeah, I think, yeah, you're right about that one.
Okay.
Okay,
And
so,
then Kylie looked at me and I.
yeah, I had it backwards, right?
So A,
Yes.
right?
Yeah, A, G.
And then F
Well,
and D,
I couldn't tell.
and then G,
What is that
and
even?
then K and B,
Can
How
we?
in the world? That's what happened.
and then L and
I
J,
think it's a
Yep.
square and then
and
L
then
is.
C.
Okay, so I just.
And then H and M. And
Sure,
then
that's
I.
fine. I had seen that originally.
Okay, we'll see.
Yes.
Where'd you put L?
Okay,
This
so
is what I have.
J and L. I can't.
Okay.
Oh, wait, I already did L. No, you
I
already
put
did
A
L.
into quadrilateral.
Is that right though?
Quadrilateral, but I'm not sure where to put H
Wait,
now.
F,
H goes in a rhombus.
because F has parallel sides. Oh my goodness.
Do
you want us to turn this thing?
No, let's discuss. Alright, what'd you guys get for quadrilateral?
A.
A, good. Trapezoid,
F and D.
good. Parallelogram,
E.
good. If you did kites, you would have E and I. Good. Isosceles trapezoid,
G.
rectangle,
Oh,
J and L. Rhombus, good, and a square,
C.
C, good. And you can use that to help you study for the true or false part. If you're going from bottom to top, it would be true. So like square is everything above it. If you're going from top to bottom, it would be false. If you're going from parallelogram to rectangle, that would be false. Okay, but again, the kites won't be on there. Yes.
Can you explain the difference between an isosceles trapezoid and a trapezoid?
An isosceles trapezoid has the legs are congruent.
Okay, thank you.
Just like an isosceles triangle has 2 congruent sides.
Oh, because if you go up, then. Okay. I see.
Okay? Alright. Quiz tomorrow. Does everybody feel prepared? No? You don't?
I'll study tonight though,
Okay.
then I'll feel better. Thank you.
Thank you.
I don't know if you, with quizzes, if you'd rather do it or if you still want to work through like social type thing.
I'll ask my dad. See what he wants to do.
Okay, I can give you the list of
Okay,
if you want.
okay, thank you.
And if you want to take the quiz and you just need extra time, you can do that too. Okay.
Morning.
Why is it snowing?
I saw this morning it said 1 to 2 inches.
Yeah, I
But
know.
last night I checked and it said
Because we're getting like the
none.
lake effect. Look at this, it's accumulating.
1 to 2 inches.
1 to 2 inches is nothing.
No, well not compared to what.
Not bad,
We have
I mean, but
before.
still, that's
It's like,
significant amount, enough to like,
Did you drive here today?
yeah.
Or you-
But I was fine, but like, I'm gonna, like, I have to go to Chicago this weekend. So, no, my mom, but still.
it might not snow.
What are you doing there?
I have a ballet audition.
Like, I think we're supposed to get a few inches.
That's not that bad.
Well, it's like really bad when you're driving.
Is that for like a
They
summer
clear the
program?
roads.
Yeah. And
Yeah,
if
but
we're
not
driving
like
on
if
it
it, like-
constantly, it's gonna
'Cause if
be
it's a
clear
little-
pretty quickly.
Thin sheet, you know, like it's not like they're gonna get the cow guys out.
Good thing it didn't like rain and snow.
But
Yeah,
it's
the
gonna be
ice on
dry.
top of the snow.
Yeah,
So it's gonna be clear better than we even.
I wanna live in Florida.
The only things that would be bad are like the additions that you live in.
Yeah.
That's true.
Or like the countryside.
It's not gonna be as bad
as
as
what happened last week.
last
This
week.
is
Oh
like-
my gosh.
I wasn't even that scared to drive in last week's weather. I was
You
just like, I
should
just
be
want
a
to leave
little
my
bit more
house.
scared.
I mean, you have a four-wheel drive though.
I just like to leave my house.
you.
I don't like to be
No.
You don't have 4-wheel drive?
But your car's big and heavy,
But it's
okay,
big
so
and heavy, but it doesn't have four-wheel drive.
it weighs it down, so it's.
As long as you drive slow and you watch out for all the people around you.
There was this one
To watch
time,
our front.
well,
Yeah.
like it was like 2 winters ago, and it was when
People drive like
my
idiots
sister was
in
driving,
snow.
and like we were like gonna try and pull in here, and like this person was like coming, like we were going this way, and this person's going here, and they have a red light, but they couldn't stop, and they were slipping.
Yeah,
And they like about like
Did they hit you guys?
no, like cause like they like sped up. But if she hadn't, we would have gotten a horrible car accident. I can imagine what it's like in like really snowy places that have like a lot of mountains. Yeah.
They're just really prepared to like clear the roads and stuff.
My mom like, cause she used to live in Colorado, and she's like, how they have to like get the chains on the tires.
Yeah, that's whenever we used to go to Mammoth. We used to go to Mammoth every winter whenever we lived in California. And we used to have to put chains on our tires once we got to a certain point, or else we could not drive the car. We still have a Suburban back then.
Like honestly, like it's scary not to drive on close when you're in the summertime.
Chained on your tires.
Yeah,
Yeah.
because it gives it more traction.
Uphill and there's a lot of snow. So
Yeah.
yeah, makes them look easy.
It's a lot of work too, because you have to like fit it over the tire.
Okay, so I did ask you to write these for your homework. We kind of did some of this yesterday, with your worksheet in class. So the addition of 3 or more right angle vectors, doesn't matter what order you add them, you will get the same answer. So, we rearrange the vectors so that the north and south vectors combine to form one north or south, component, and we combine the east and west vectors to do the same. So, let's do this example together. A student drives his car 6 kilometers north before making a right-hand turn and driving 6 kilometers to the east. Finally, they make a left-hand turn and travel another 2 kilometers to the north. What is the magnitude of the overall displacement of the student? So, if we look at the north and south ones, we can combine those together and also combine together the east and west, which there's only one of those. Then we can make our triangle appropriately. So it goes 6 to the north, and then 2 more to the north, and then it goes 6 to the east. So our resultant will be here. And those will combine to be 8. So we'll have 8 and 6, and here's our theta. So how would we find the magnitude? I also want you to find the direction. It says magnitude, but we can find both. So how would we find the magnitude of R? Right, Pythagorean theorem, good. So R squared would equal 8 squared plus 6 squared. So R will equal
Articles 10.
10? Good, thank you. And how would we find the direction?
Inverse tangent.
Yes, so I'm gonna start by saying the tangent of theta is what?
6/8.
6/8, opposite over adjacent, so it's gonna be the inverse tangent of 6 divided by 8.
.8.
Okay, good, so let's just go ahead and round to the nearest degree, so we'll say 37 degrees. And then we do need to figure out what that would be CCW.
Do you add it to 90?
It does form with the 90, but in this case, we are going to subtract it. So it'd be 90 minus 37,
53.
so 53 CCW. So the resultant would be 10 kilometers in 53 degrees CCW. Okay? Any questions? Alright. And then, the addition of non-perpendicular vectors. So that is what number 4 was on the worksheet, which I told you you didn't have to do yet. Some of you already attempted it, and maybe after you saw the notes you were confirmed that you were doing it correctly. But if we have any non-perpendicular vectors, they're not 0, 90, at 180, or 270 degrees, we can break those into their components that are perpendicular vectors, which we had been doing yesterday, breaking vectors into their components. And then we can use the 2 components. So it makes more vectors, but it's going to simplify so we have a right triangle in the end. So then we can do the same thing we did with the perpendicular ones and rearrange them all so that the north and south go together and the east and west go together to make a right triangle. Okay? So there's a lot to this problem. Cam, Kerr, and Baxter Nature are on a hike. Starting from home base, they make the following movements. Determine the magnitude and the direction of their overall displacement. So, unfortunately, none of these are nice to work with. They're all not perpendicular. So, we're going to need to figure out the components of each one, and then we're going to have to combine all of the north and south and combine all of the east and west. So, I would first suggest you draw a picture for each of these movements so that we can figure out how to calculate the components. So if we start with A, just sort of estimating where 140 degrees CCW would be between 90 and 180. So it's going to be somewhere going to the north and to the west. And we know that its CCW is 140. And then we have B, which is 252, so that's going to be going to the south and to the west. Since it's between 180 and 270. that is 250.
That's you.
Thank you.
And then we have C, 332, so that's gonna be going to the east and to the south, southeast, since it's between 270 and 360. Okay, so then we need to find the components. So in A, what two directions are the components going to be going? The X and Y components will be going which directions? For A.
Northlands.
Good? So we'll have an X component this way and a Y component this way. And so if you see where this triangle is forming, the 140 is going to help us figure out the angle that we need, but it's not the angle that we need. So we need to figure out what this angle is right here, which would be what?
40 degrees.
Good. Okay, and B, which two directions are the components going?
South and west.
Good. So this is the Y component and here's the X component. And again, we're gonna have to figure out the angle that we need because we only have the CCW, so what would the measure of the angle that we need be? Good? How did you calculate that?
270 minus 252.
Good. And then for the last one, which directions are the components going?
South and to the east.
Good. So there's the Y component and the X component. And what is the angle that we want for that?
28 degrees?
Hmm?
28 degrees. Because it's 360 minus 332, right?
Well, 360 minus 332 would give me this angle.
So it'd be
62.
So we want to do, did you do 332 minus 270?
Yeah, 62.
Okay, good. 62. Okay. And now, since this is a very complicated problem, I would maybe suggest a chart. So we're going to have our A vector, or let's say we have the vector, and then we're gonna have the east and west component, or let's say the X components. And then we're gonna have the Y components, and then we're gonna combine them. So for vector A, how would we calculate the X for that triangle?
That would be what?
How are we gonna find this X using this right triangle?
Cosine of 40.
Hmm?
Cosine of 40.
Cosine of,
I guess we have to find the hypotenuse first.
oh, they gave those to us, we should put them on there. This is 2.65. 4.77 and 3.18. Okay, so yes, we have 40 degrees. The X component is the adjacent angle to the 40, or the adjacent side to the 40 degrees. So it's going to be cosine of 40 equals X over 2.65. So in other words, X will equal, it would be 2.65 times the cosine of 40. Which is and we want to indicate the direction that it's going so that we can combine them later on. If it would help you, instead of saying east to west, if you want to call the west ones negative and the east ones positive, then it might be easier if you're adding them in a long list like this, or you can call them east to west. And then y would be what, or how would we calculate that?
Sine of 40.
Good, the sine of 40 would equal the y divided by 2.65. So again, it will be 2.65, and this time times the sine of 40. And that one is going north. Okay, and then we have to do the same thing for B and C. So see if you can do that for B and C. Okay, so that's what you should get for the components, the X and Y components for A, B, and C. And now we need to combine them so that we have one single X component and one single Y component. So, we could add the two west components together and then subtract the east component from it. Or we can subtract the two west components from the east component. What would you get if you combined all of those X components? And in what direction would it be going? Alright,
I got 0.697 less.
oops. Yes. Good. And what about the Y components? Right.
I got 4.325 south.
Good. Okay, so with that, we can make a single right triangle, which will make our lives much easier. So it's going west and south. And then we can find our resultants. So you'll have r squared equals plus
I got 19.4, but then you have to square it.
yes.